So let's jump to number 18. First thing we need to remember is that when you have a negative exponent, you need to grab that whole thing and move it to the other side. So this whole term right here, I'm going to move it underneath, and it's really going to be 6y squared minus 5y minus 15 divided by 2y plus 3. So this problem that originally looked like a multiplication problem became a division problem. So now we're going to set up that division problem with long division. Okay, so when you do long division, make sure that every exponent is represented and it's in order from highest exponent down to smallest. So you have 6y squared, you have minus 5y, you have minus 15. And it's divided by, you're going to put the 2y plus 3 on the outside. You follow me? Okay, so now it's a question of looking at your first term 2y and your first term 6y squared and ask yourself 2y times what will give you that exact value 6y squared? 2y times 3y will give you a 6y squared. So I'm going to put that 3y right on top of the 5y. I want to stay organized. The y's on top of the y's. Y squares on top of y squares, numbers on top of numbers. So I just said 2y times 3y will give me this first term 6y squared. So that's why I wrote 3y up here. It's kind of like doing distributive property. 3y times 3, that's a 9y. And that's positive 9y. And then 3y times 2y, that is 6y squared. You guys following me? Now this is subtraction, so I'm going to put in parentheses and put a minus sign on the outside. So that's really like if I were to distribute the minus sign, I have a minus in there and I'll have a minus over here when I distribute it to both. So if you think about positive 6y squared take away 6y squared, it cancels out. And if you have a minus 5y and a minus 9y, you end up with minus 14y. And of course we're going to bring down the minus 15 and have minus 15 right next to it. So at this point, once again, we're going to go 2y times what will get us a negative 14y. That's going to be a negative 7. Why negative 7? Because negative 7 times 2y is negative 14y. And if we were to distribute negative 7 times 3, that's negative 21. Now we are subtracting, so you have to put the binomial in parentheses with the minus on the outside. And then you're going to take that minus sign and distribute it to change those signs. So you really do end up with a negative 14y and a positive 14y that cancels out. And you really do end up with a negative 15 and a positive 21. That is the remainder of 6. Now, what do I do with the remainder? I write it over the original 2y plus 3. So, since my answer is 3y minus 7, I'm also going to put plus 6 on top over the original divisor 2y plus 3. And ladies and gentlemen, that's my final answer for that question. So, I want to erase this and try another problem. Let's go with the... Let's try number 23. So, which one belongs inside of the box, inside of the division box? What belongs on the inside? 4p to the 4th plus 0p to the 3rd. Notice that there is no p to the 3rd. So you need to represent the p to the 3rd that there is no p to the 3rd. So you put a 0p to the 3rd right there. And then you continue with minus 17p squared plus 14p minus 3 at the very end. And on the outside, is the divisor, and the divisor happens to be 2p minus 3. That's how you set it up. You make sure that your expressions, your polynomials, are in standard form, highest exponent, 4, 3, 2, 1 number. From highest to lowest. Now notice there is no p3, so you have to still write it with the 0 in front. 0 represents that there is no p to the third, but you still need to represent it on your division problem. So what am I going to do? I want to go 2p times what will give me a 4p to the fourth. 2p times what will give me a 4p to the fourth. 2p to the third is the answer. Now where am I going to write 2p to the third? I'm going to write it right on top of the 0p to the third. That's why I put the 0p to the third, because you need to stay organized. Okay? So 2p times 2p to the third, let me write it up here, 2p to the third, that will give me 4p to the fourth. So when I distribute, I want to get a 4p to the fourth right here. And when I distribute 2p to the third times negative 3, that's going to give me a negative 6p to the third. Are you with me? And of course, I am going to subtract. So this really becomes a minus 4p, and it really becomes a plus 6p to the third. And now when I look at the positive 4p to the fourth minus 4p to the fourth, that really does cancel out. And when I look at 0p to the third plus 6p to the third, that's still 6p to the third. Yes? Now what do I do next? I bring down the minus 17p squared. I want to take this minus 17p squared and I want to bring it down. It's going to be minus 17p squared right there. And then once again, you go for your first term. 2p times what will give me this exact 6p to the third? Once again, 2p times what will give me this 6p to the third? It's going to be positive 3p squared. And notice that my p squared is on top of my p squared on top of my p squared. Everything's organized. Okay? So I'm going to distribute 3p squared times 2p. That is 6p to the third. That'll be right here. 6p to the third. And then 3p squared times negative 3. That will be negative 9p squared. Now, keep in mind that we are subtracting. Estamos restando. We're subtracting. So we're going to have a minus sign out here, which means that when you distribute that minus sign, it's going to become a negative 6p to the third, and it's going to become a positive 9p to the second. Are you with me? So the 6p to the third and the negative 6p to the third cancel out. The negative 17p squared plus 9p squared is 8p squared. And of course, let's not forget that it's negative. And then after that, we're going to bring down the 14p, the positive 14p. We're going to put plus 14p. And once again, 2p times what gets us the exact value, negative 8p squared. You want the same exact value. So 2p times what gives us a negative 8p squared? That would be a negative 4p. Isn't that right? And when I distribute negative 4p times 2p, that'll give me the negative 8p squared. And when I distribute the negative 4p times the negative 3, that'll give me a positive 12p. Now we are subtracting, and because it's a binomial, you need to put parentheses with the minus on the outside. And when you distribute the minus sign, it's going to change this to a positive, and it's going to change that one to a negative 12. So, the negative 8p and the positive 8p, those guys completely cancel out. And then the positive 14p and the negative 12p, that ends up being a positive 2p. And the final thing to drop down would be that negative 3. So you put a 2p minus 3 right there. And once again, the final step would be 2p times what will give us that exact 2p value. That would be 1, right? Positive 1. So you go positive 1 and give me a second. So when I multiply it by 1, if I distribute 1 times 2p is 2p and 1 times negative 3 is negative 3. So you will get 2p minus 3. And of course you are subtracting. And that'll distribute to make it a minus, distribute to make it a plus. Which means that they all cancel out. Which means that there is no remainder. So this is your actual answer right here. No remainder. This is it right here. There is your answer. That was a hard one. It took a long time. What do you guys think? So this whole assignment, I only want you to do the second half of it, numbers 18 through 24. If you have any missing values, like right here, there's a missing value, h squared. You're not going to put h squared minus 1. I would go h squared plus 0h minus 1. I would put the 0h right there, that there is no h. Should we do another or just give you time to do it?
No.
That's it? That's it. Good luck.